Hello everyone, I am Dr. Godandaraman. In this section, we are going to discuss with harmonic conjugate harmonic f of z type of problem. Look at this problem. Prove that u equal to x cube minus 3xy square plus 3x square minus 3y square plus 1 is harmonic. Also find the conjugate harmonic function v and the corresponding analytic function u plus av. Here in this problem, three type of question to find. One is u to prove u is harmonic, and then find the conjugate v and then find f of z. So this is a three type of questions here given. So first of all, u is given. When u is given, to find the harmonic, u is given. Therefore, if u is given and then if you want to prove it's harmonic, to check the given function is satisfied Laplace equations or not. If the given function satisfies Laplace equation, then the given function is harmonic function. What is the Laplace equation? Laplace equation is nothing but u is given. To find u xx, u yy, when adding these two values 0, then the function satisfied Laplace equation. Therefore, u given u equal to x cube minus 3xy square minus plus 3x square minus 3y square plus 1. First, partial derivative u with respect to x, ux. So x cube, differentiation of x cube 3x square minus 3 constant, x differentiation 1, y square constant, so in product no change, plus 3 constant, x square differentiation 2x minus 3y square constant, when I am constant differentiation is 0, plus 1 differentiation 0. Therefore, the value is nothing but ux equal to 3x square minus 3y square plus 6x. So this is a ux. And u with respect to y, uy, x cube constant, when I differentiation with respect to y, here x cube constant, therefore 0, minus 3x constant, y is only variable, y square differentiation 2y, plus 3x square constant 0, minus 3 constant with the product y square derivative with respect to y, 2y, plus 0 constant. Therefore, this is a minus 6xy and minus 6y. This is a uy. Now differentiate with respect to again equation 1. This is the equation 1. So differentiate 1 partially with respect to x. When I differentiate partially with respect to x, again u xx. When 3x square, 3 constant, x square derivative 2x minus 3y square constant 0 plus 6x derivative 1. Therefore, uxx equal to 6x plus 6. Now I consider this is the equation 2, this is the equation number 3. Now differentiate 2 partially with respect to with respect to y. Now uyy equal to minus 6x constant, y derivative with respect to y 1, minus 6 into 1. Therefore, minus 6x minus 6 uyy. Now I consider this is equation 4. Adding equation 3, 4. So uxx plus uyy equal to 6x, what is the value? 6x plus 6 minus 6x minus 6. So when I cancel this 6x, the value 0. Therefore, uxx plus uyy 0. uyy 0. Therefore, Laplace equation is satisfied. If the given function satisfied this Laplace equation, therefore u is harmonic function. So hence proved u is harmonic. The first one is over. The second one and third one. See, the second one conjugate harmonic and third one analytic function. See, we have some method. Method 1, now u is here, then to find the v. So how to find v? First u given, from this to find v, correct? U given, find v using the conjugate harmonic formula. Conjugate harmonic formula. And after that, okay, now this is a v, conjugate harmonic. Now if you know u and v, then to find f of z, u given, now v substitute, then simplify this in term of z term. Simplify in term of z, then this is a method 1. And method 2, u is given. Okay, now to find first, to find f of z using Milne's Thomson method, to find f of z. So when we are finding f of z, from this equation rearrange, then to replace in the form of u plus iv, to just rearrange in the form of u plus iv, from this to find the v value. Then method 3, u is given. Now v to find using the formula conjugate, then f of z to find using Milne Thomson, whatever. So this 3 way to calculate the given problem. So now I am going to apply with this third method. Third method means using conjugate separate formula and using Milne Thomson method. So both method to apply with in this particular problem. Okay. Now first here conjugate harmonic function. Conjugate, to find this conjugate harmonic function. So when u is given, to find v. So this is a conjugate. Now how to find the direct formula? So dv equal to vx plus vy. So this is a normal formula to calculate vx. So vx is nothing but ux vx. So dv equal to vx plus vy. So vx into dx plus vy into dy. So this is a directly derivative dv equal to. So dv equal to vx dx plus vy dy. But the problem is u is given. When u is given, using this CR equation, using CR equation, ux equal to vy, uy equal to minus vx. This concept to apply with this part. Therefore vx equal to minus uy dx plus vy equal to ux dy. Therefore taking integration, v equal to minus integration of uy dx plus integration of ux dy. This formula only given directly. This formula only given directly. So this is understand purpose I am writing, otherwise direct to apply with, when u given v find, use this direct formula v equal to minus integration of uy dx plus ux dy. For here v equal to minus integral uy value. What is the uy? Equation 2, minus 6xy minus 6xy minus 6. So this is the uy. uy 6xy 6y into dx plus integration of ux. So ux is nothing but equation number 1, 3x square minus 3y square, 3x square minus 3y square plus 6x into dy, into dy. Now to integrate with respect to x, therefore integration of, when I am taking minus common, it will be plus 6xy plus 6y into dx plus 3x square minus 3y square plus 6x into dy. Now integration with respect to x, therefore 6y constant when x integration is x square by 2 plus 6y constant when integration dx x plus, for this term 3x square integration with respect to dy, 3x square constant, dy integration is y minus 3, y square integration is y cube by 3 plus 6x, then dy is y. So this is the first term, this is the second term. Now to cancel this common term, any common, so this is a 3 times of, and this 3 cancel, therefore 3xy square plus 6xy plus 3x square y, so this is a 3x square y minus y cube plus 6xy. For this term, to write 3x square y plus 6xy, please don't add this term because of repeated term is ignore. Repeated term means this term and this term 3x square y, 3x square y. So only write one time, the repeated term is ignore. And this term to ignore, and then minus y cube. And then ignore 6xy already written here, 6xy. So this is a v term. Now this is a conjugate harmonic. See, I mentioned that this is a direct finding. So suppose to find f of z, given u plus I into this v, to simplify, then convert into z term to find f of z. This is a one method. Now using Milne-Thomson method to find f of z when u is given, using Milne-Thomson method. So what is the using Milne-Thomson method? F of z equal to integration of, when u is given, therefore pi 1 of z comma 0 dz minus I into integration of pi 2 of z comma 0 dz plus this constant, where pi 1 of z comma 0 is nothing but ux with respect to x replace z and y replace 0, then pi 2 of z comma 0 uy z comma 0. So this is a formula for calculating f of z. Now pi 1 of z comma 0 ux of z comma 0. So what is the ux? Ux is nothing but 3x square, right? Ux 3x square minus 3y square plus 6x. 3x square minus 3y square plus 6x. For this form, replace z comma 0, where x substitute z, where y substitute 0. Therefore 3z square minus 3 square plus 6 into z. So therefore the term 3z square plus 6z. This is a pi 1 of z comma 0. Then pi 2 of z comma 0 uy of z comma 0. Now what is the uy? Equation 2 minus 6xy minus 6xy minus 6y. In this function substitute z comma 0. What does it mean? That where x substitute z, where y substitute 0, therefore minus 6z 0 minus 6 0, the whole term 0. So pi 2 of z comma 0 value 0. Now what is the f of z? Integration of pi 1 of z comma 0 dz minus I into pi 2 of z comma 0 dz. Now substitute integration pi 1 of z comma 0 value 3z square plus 6z into dz minus I into 0, the whole term 0. When I am integrating the whole term 0, integrating the first term, 3 constant z square integration z cube by 3 plus 6 z integration z square by 2 plus the constant. Now cancel this 3 and 3 times of this equation. Therefore z cube minus 3z square, then see this is a function of z. So this problem we solve 3 category. One is U to prove that harmonic and conjugate harmonic function to find v value, and the f of z to find using Milne and Thomson method. Thank you.